So for today, I am going to do a little bit of review, and then the main review day is Tuesday. Of course, you have Monday off for President's Day. So Tuesday we review, and then Wednesday's the test. So really, I only have to teach you one more thing, but I'm going to start with the review, and then I'm going to teach you the new thing later. All right, so here's the review. My gosh, if you haven't figured out by now how these go, where have you been? This is the kind where I am not sure how many triangles this will make. And this is unknown down here. Please draw this picture. And this is going to be a 20-degree angle. And if I said this side was 1, would you agree it's unlikely that that would touch and it wouldn't make any triangles? Okay. Well, you won't really know for sure, though, until you figure out this side that would make a right triangle. If you drop that down, you all of a sudden have your third piece of info. See, you only have 2 pieces of info, and then all of a sudden, oh, I made a right triangle. Now you have 3 pieces of info. Now you can do, well, actually the law of sines is the really slow way. So don't do that. Just do sine, cosine, or tangent of the 20. And then let's call this A. I know we could call it H, but do you get H isn't a great variable because it stands for height and it stands for hypotenuse? And that can be confusing. Let's call it A. Would you please figure out how long A would be if this is a right triangle? Can you pause for a second? Well, you do that. So by now you've figured out that it's sine of 20 equals A over 12. You times by 12 on both sides. 12 sine of 20. On the ACT, that's how they'd leave the answer. Because the ACT needs to have the test be accessible, even for kids that don't have a calculator. And nobody knows what sine of 20 is unless they have a calculator. You know what I mean? Like, that's not something you would memorize. So only kids with calculators would get it right. That wouldn't be fair. So on the ACT, the answer would actually read 12 sine of 20. Okay, but for you guys, you had a calculator. And if nothing else, you could use your iPad calculator. On the test, you will have a calculator. I thought we wouldn't, but we did. And so your final answer, Graham T. 4.1 is A. Now that is, as soon as you know that, I'm going to put the 4.1 here, that tells you what lengths of sides would cause 2 triangles. Does 4.1 cause 2 triangles? No, that causes 1 triangle. That's this triangle right here, and there's no other way to make that be a different triangle. If it's 4.1, it's straight up and down. There's only 1 triangle. But do you get if it was a little bigger than 4.1? Then there would be 2 triangles. Think about it. This wouldn't fit if it was actually 5. Like, you'd have to go at an angle like that. And then there'd be another end like that. Do you get if it's 5? It would be the indeterminate case. There'd be 2 triangles you could make. All right. Let's call this... Oh, wait. First of all, I want to know, what are the lengths of sides for A? That's that little side that we're dealing with over here. This little side, this is big A, so this is little a over here. What are the lengths of sides that would cause the indeterminate case? In between this and that. Don't say it. Write it down. The ones that would be like 2 triangles would be between this and this. If you missed a memo at some point, you wouldn't know this, but it's between 4.1 and 12. Those are the lengths. If they're a little bigger than 4.1 and a little less than 12, then all of those lengths, like 5, for example, would cause 2 triangles. All right, so now we're going to assume it is 5. And that means I get to erase all this, and then there are 2 triangles. The side swinging out this way, I'm going to make a different color. And then this one. So do you get it could be like the black side that's 5 or the red side that's 5? All right. Then we're going to call this C at the top. And we're going to call this B at the bottom. And it's unknown whether it's B1, B sub 1, or if it's B sub 2. then I'd like you to figure out that angle, angle B. Well, if you figure out one of them, you'll automatically be able to tell the other one. So this one will require the law of sines. It's a good review because that's one of the biggies on this test, law of sines. And of course, the last thing is law of cosines. But right now, use the law of sines to figure out angle B1 or B2. And hopefully you'll be able to tell. You might try to find B2 and then like, crap, I guess I found B1. All right, pausing while you try that. To get the kid started who is stuck, I would just say use sine of 20 with 5. And the angle we want is B, right? Sine of B1. And see if you can do it from there. Okay, so I really could have just started with this thing I wanted and then put it over the side across from it, which is 12, and then did the other part. But it doesn't really matter what order you do it in. I like to do it with the angle on top, though, because that's the thing I wanted, and it means one step. I just had to do one step. If that variable had been on the bottom, it would have taken 2 steps. So one step's way better. So 12 times the sine of 20, and it all divided by 5. Ari, what did you guys get? Inverse sine at the end. Final answer? 55.17. Within the rounding, like who would have rounded at least in that neighborhood? Raise your hand if you had something similar. Okay, good. Now on the test, how do we handle that? There is only one right answer if you round it to the exact spot. And I can't just say, oh, he was close. Well, I can, and I can give you part credit, but you can't have full credit unless you're exact. I'm not saying that Ari's is exactly perfect, because I actually didn't do it. But do you know how you can be as perfect as possible? Don't round until the very end. And at the very end, you take your answer and you round to the right place. Because, see, along the way, if you took this and you rounded it a little bit, and then you do your inverse sine, well, now the further you round, the further off you get. Okay, so that's called the indeterminate case, because you can't tell whether this angle is 55 or, I'm rounding now to a whole just to make my life a little simpler, and then this would be 55, or if it's this angle, which is 125, I think. 125 here? All right. 70, 80, yep, adds up to 180. Okay. So, how many of you had that one right? Raise your hand if you're good on that kind. Okay, good. Then that was law of sines. We've already practiced law of sines. When do you use law of sines? This is really important. When do you use law of sines? Angle and the side across from it. Okay, so when do you not use the law of sines? When you don't have an angle and a side across from it. So like if I have 40 degrees here and I have this is 8 and I have this is 7, do I have an angle and the side across from it? No, then I have to use the law of cosines now. And let's find the length of this red side there. Now, I didn't put any letters on it on purpose because I want you to figure out what letter should go where. Because you always get to decide that. Even if I'd call it FRK, you should label it with the right letters, which are A, B, and C, of course, but you should know which one is C. And let's save some time. You either know it or you don't. Which one's C? The 40. Because we only have one angle in the whole a squared plus b squared minus 2ab cosine of big C. There's the only angle right there. That's the only angle in the whole formula. You need to make that your C. Remember, the goal here is to find this side right here, which I'm going to call little c. All right, wait till the other person is done, and then ask them if you would compare. Pause for a second. Okay, so Garrett says he's done. What are A and B here, Garrett?
Well, I made B 8.
All right, so this will be 7. squared plus 8 squared minus 2 times 7 times 8 times cosine of 40. This is one you can just put all into the calculator all at once if you're careful. And then at the end, you take the square root of it. And what did you get?
5.22.
5.2. Raise your hand if you had about 5.2. Okay, good. Do you get that means you know how to use the law of cosines for that kind of problem? There's one other kind, and that's where you don't know the angle. Let's do that one. 3, 5, 6. That for sure is not a right triangle because I know it. I know those combos. 3, 4, 5 would be a right triangle. This is not a right triangle. Maybe I made it look like a right triangle, but it's not. That angle, it looks like it's 90. It's not 90. Would you please figure out how big that angle is? Use the law of cosines. Go ahead, and it'll work. Pause for a second. Can you shut the door on your way out, too? Okay. I hope you knew this was C. It's the angle you care about. I don't even have an angle, so it's the angle that I want then. All right, so that's C. C is the key. All right, and A and B don't matter, right? So they're the other ones. I'm going to label them, though, so I don't get confused on what's A and B. I personally pick those. And then I go A squared, which is 5 squared, plus B squared, which is 3 squared, minus 2 times 5 times 3 times cosine of big C, which we don't know, equals 6 squared, which is 36. And now I'm going to go 25 and 9 makes 34, minus 2 times 5 is 10 times 3 is 30. Cosine of big C equals 36, subtracting 34 from both sides. And I get negative 30 cosine C equals 32. No, not 32, 2. Just 2. Just 2. And then I'm dividing both sides by negative 30. Cosine of big C equals, well, I can just get a decimal for that. What is 2 divided by 30? 0.066. It keeps going. And then I'm going to do inverse cosine of that. I need a calculator for that. Inverse cosine of negative 0.0667. 93.8. Do you remember me saying it wasn't 90 degrees? Turns out it was 93.8 degrees. That make sense to you guys? How many of you guys got that one? Okay, cool. Now, this is a common trap. Because what if I say, I want this angle? A lot of people are like, well, I guess I got to use law of cosines again. Why would you not use law of cosines now? Yes?
Her calculator's broken.
Okay, we'll talk about that later. I want to answer this question. Focus. Why would I not use the law of cosines now? Yes? You got the angle on the side across from it, so you can use law of sines now. Everybody do that and figure out this angle I called A. Everybody find out that angle. Notice we are not using the law of cosines now. Molly, you want to trade for a calculator?
Oh, I can just use my iPad one.
Okay. Do you want me to reset your calculator to factory new?
Sure.
Okay, so our next job here was to use the law of sines because we had an angle on the side across from it. So I'd start with that. No, wait, actually I wouldn't. I would start with the thing I don't know. I need A, so I'm going to start with big A. So if I'm using the law of sines, that's going to be sine of big A over, and what goes with that? The thing across from it, which is 5, equals, and then it must be a sine of something. And then I'll use the other angle I have, which is sine of C, which is 93.8. Over 6, and look at that. If I times both sides by 5, I'm just going to put the 5 in front, though, so that you don't by accident think it's 93.8 times 5. I'm timesing by 5 here and here. And then I do inverse sine of all that. Let's save some time. What did you get for that one, Alex K? The answer to this problem, A. What is angle A? Anybody verify 56.3? Oh yeah, lots of people. Cool. Again, that was all of this becomes a decimal, and you inverse sine of that, 56.3 degrees. Okay, cool. So do you get how law of cosines then led to using law of sines right after it? All right, cool. We've covered everything except the last melon, the last thing I have to teach you, and then all it is from there is review in the test, okay? Here's the last thing I got to teach you. Do you get that when there's a 3, 4, 5 triangle, it is a right triangle, and everybody should know how to find the area of that? Just rack your brain for a second for what the old area formula was, and then don't say it out loud, but would you please write down what you think the area of this thing is? Don't say it, write it. You probably learned this in either the elementary school or the middle school, one or the other. Base times height, divide by 2. 3 times 4 is 12, divide by 2 is 6. Who had 6 written down? Okay, good. Now I'm going to show you another way to get area of a triangle when you don't have a right triangle. Because see, if it's a right triangle, that's what you do. We're done. But what about a non-right triangle? Well, let's take a classic non-right, which is where all the sides are like not 3, 4, 5, like 3, 5, 6. That is, we just established that is not a right triangle. You know what I mean? We just did that problem a minute ago. That is for sure not right. It would be a 3, 4, 5 if it was a right triangle, right? Okay, so 3, 5, 6 is not a right. I know I drew this close to a right, but it is. It's actually pretty close to a 90, but I'll make it a little more exaggerated. It's bigger than 90. So that's not a right triangle. So you can't use that to get the area. So what do you do? All right, well, there's two choices. You can find an angle. Would you agree with the law of cosines? We could find an angle. Okay, and we can get it from that angle, but I'll show you how in a minute. Or we can do this other formula for finding the area of a triangle, which is kind of cool. And it goes like this. Write it down. You'll never remember it unless you write it down. Area is, and it's got a big square root. So again, what we're doing here, the reason you want this is you can get an area of a triangle that's not a right triangle by just using this little formula. Garrett, you need to remove this. I know you probably forgot it was there. I was walking around this morning with my headphones in for 20 minutes without any music playing. I'm like, oh my gosh, I have headphones in. So I'm sure that's what's happening to you. Anyways, S times S minus A, S minus B, and S minus C. Would you agree A, B, and C are probably the lengths of the sides? Okay, and do you get that it really doesn't matter too much because you're going to use A, B, and C in the exact same way as each other, so it doesn't even matter which side is which. But then what the heck is S? Does anybody know this one? One kid last hour knew. Okay, S, you better write this above it. S equals semi-perimeter. Obviously, that's related to perimeter, but let's think it through a minute. Perimeter would just be add up all the sides. Semi-perimeter, does anybody know what the word semi means? Half. Very good. If you've got all those memorized, you really are doing yourself a big favor for the future because things like semi-perimeter become obvious, like, well, duh, it's half of the perimeter. And if you don't memorize things like kilo, you know what kilo means? No. Kilo means a number. 1,000. So kilometer means a kilometer. But see, kilo doesn't mean a kilometer. Kilo means 1,000. So kilometer, 1,000 meters. You guys know what mega means? You guys should learn those. So anyway, semi means half. You guys know what bi stands for? 2. So if I say like bi-monthly, that means like 2 times a month. All right. So anyway, those little prefixes are a little powerful tools. This semi means a half, so it's half the perimeter. Let's find the perimeter. 6, 7, 8, 9 plus 5 is 14. What's the semi-perimeter then? 7. Everybody put a 7 on top of all your S's. Do you get now? I just have to put in the A, B, and the C, and it's going to be super easy. And it doesn't matter, so just put one in each spot. 3, 5, 6. Pick A, B, and C to be 3, 5, and 6, and it doesn't matter what order. So now, square root of 7 times 7 minus 3 is 4, times 7 minus 5 is 2, and 7 minus 6 is 1. And 4 times 2 is 8, times 7 is 56, square root of 56. Now, I don't happen to have that memorized, but I could say, would you agree that's fairly close to the square root of 49? It's a little bigger than that, right? Square root of 49 would have been 7. So the area of my triangle is a little bigger than that. So square root of 56 is the area of the triangle. All right, now, if you actually understood that, then you'll be able to do it on the 3, 4, 5 triangle. And I know the answer already. We just did it a minute ago. 3 times 4 is 12. The answer is 6. But I want you to do the semi-perimeter thing, and you'll see the answer comes out to 6. But the question is, can you do this formula? Yes?
On the test, would you like us to actually calculate it's not like
You need to show your work on the test. So let's show you how I would want you to show your work. Do I need you to write out the full formula? No. But do I need you to write out some of the numbers in the formula? Yeah. So for instance, here's the formula. If you had just written in all your S's as an actual number, 3 plus 4 is 7 plus 5 is 12. So the perimeter is 12. So what's the semi-perimeter? 6. 6, 6, 6. And then you had written in what A, B, and C are. 3, 4, 5. That would have been perfectly good work. And then from here, I get a kid can do the rest on their calculator. I would not need to see further work. So from there, I would totally understand you're going to probably type this all into a calculator. I'd do some of it in my head, though. 6 times 3 times 2. I would have personally done 6 times 3 is 18 times 2 is 20, 36. Square root of 36. Square root of 36 is 6. How could I have ever known it was going to be 6? Well, because we told you ahead of time the area is 6. But I'm just showing you how it works. Any questions? All right. Do you get how that formula will be easy to use if you know how to use it? Okay. So we're going to give you the formula. If you forget it, you're fine. It'll be on the test. If you forget how to use it, you're not fine. We're going to tell you what S is? No. You have to know what S is. S is the semi-perimeter. Yes?
What is this formula giving us
The area.
of the triangle?
Yep. So remember how I said you could do base times height. 3 times 4 is 12. Cut it in half is 6. And we knew the area was going to be 6. But I was just showing you how this formula would have also come out to the square root of 36, which is 6. So this formula would have worked. But you would have never used it because you would have used this. Way easier. But on the problems where they're weird sides, like 2, 17, and who knows what that is, and find the area of that, if I told you it was a right triangle, I wouldn't use this formula. But if it's not a right triangle, like, let me think. I think 18 could work, or do I have that backwards? No, I think 18 could work. Yeah, and then it wouldn't be a right triangle, and then you could use this formula to do it. Now, this one isn't like magical or anything. They all work. You just find the perimeter, add them all up, and then half the perimeter, and you've seen the formula already. Okay, there's one last kind, and that goes like this. This one's 8, this one's 10, and this angle is 40 degrees. I can find the area of this without having to find the third side. Because see, you know that way I just showed you, you need all 3 sides. I don't have all 3 sides. And it would be a pain in the butt to have to take a moment and use the law of cosines to find this side and then use that other formula. So there's a faster way, way faster. By the way, these are some of the formulas I teach kids to master the ACT, because the non-right triangles are definitely on the ACT. So I would want to know this one. And it is, area is, we're not doing the semi-perimeter one, we're doing a different one. 1/2, can anybody finish it? Not base times height, because this is not a right triangle. And if we knew the height, we could still use base times height. It would work, but we don't have the height. Okay, 1/2 AB sine, anybody remember? C, very good. I did mention it once in class. 1/2 AB sine C. Once again, C being the key angle. Do we have any other angles? No, so you for sure would want C to be this 40. And if that's C, then this is little c. And the other ones must be A and B. I know this chair's moving around, but we're not leaving yet. Would everybody please find the area of this triangle? Area is 1/2 of A is 10, B is 8, sine of 40. Oh my gosh, it turned out pretty cool. 40 sine 40. All right. I would tell you that most of the homework for tonight are ones you should do, so I'm not having you skip any of them. The cool part is you're already done with the Schoology quiz I gave you yesterday, so just do the homework for tonight. I'll see you on Tuesday. That's all I got for you for the video for today.